Welcome to this comprehensive tutorial on building a financial research agent using Flowise. Today, we're going to create an intelligent agent that can search for financial information and provide detailed analysis using multiple AI models. By the end of this video, you'll have a fully functional research agent that combines planning, web searching, and advanced reasoning capabilities. So let's first understand what we're actually building here. Our financial research agent consists of four main components. We have a start node to initiate the workflow, a planner using Gemini 2.0 Flash to break down research tasks, a search agent using Gemini 2.0 Flash for web searches, and finally a writer agent using Claude 3.7 Sonnet for final analysis and reporting. The workflow follows an iterative approach, which means it allows the agent to refine its research based on initial findings. We'll begin by configuring each node with the proper parameters, so let's dive right in. Step 1. Configuring the start node. The start node serves as our workflow trigger. This node creates a user interface for submitting financial research queries. First, we need to configure the form input. For the form title, we'll input financial research. For the form description, we'll write, "You are a financial research agent that takes in a query," and return a detailed report. Now, for the form input types, we'll set the type as string, the label as query, and the variable name as query in lowercase. The variable name query is really crucial here because this will be referenced throughout our workflow as form.query to pass the user's input to subsequent nodes. For the flow state, we'll input the key as search EOS key reason and the value as bar. The flow state allows us to initialize workflow variables, and here we're setting up a search reasoning key that will be used to track the research process. Step 2. Configuring the planner node. Now let's add our planner node. We'll select LLM from the Add Node button and drag it to the workspace. This uses GoogleGenerativeAI to analyze incoming queries and create a structured research plan. For the planner node configuration, we'll rename it as Planner. Then for the model settings, we'll select the model as GoogleGenerativeAI. We'll expand the parameters, then select the credential, and then select the model name. For the messages configuration, we'll add a new message, then select System Message as the role. For the content, we'll input, "You are a financial research planner." Given a request for financial analysis, produce a set of web searches to gather the context needed. Aim for recent headlines, earnings calls or 10K snippets, analyst commentary, and industry background. Output between 1 and 2 search terms to query for. We'll create another message, and this time the role is user message and the content we'll enter double curly brackets and select form.query. This setup allows the planner to receive the user's original query through the form variable and respond with focused search terms. For the JSON structured output, the key is searches, and the type is JSON array. For the JSON schema, we'll create query and reason, both with type string. The description for query is the search term to feed into a web or file search. The description for reason is your reasoning for why this search is relevant. The description for this output is a list of searches to perform. Now we'll update flow state with key as search.dr key, reason, and value as output.searches. This configuration ensures the planner outputs structured search queries that will be consumed by the iteration process. Step 3. Configuring the iteration node. Now we add the crucial iteration node, which enables our workflow to process multiple search queries from the planner systematically. This is what makes our agent truly powerful because it can handle multiple research angles automatically. For the iteration node configuration, the array input is flow.state.search key reason. This references the flow state we set up in the planner, which contains our array of search queries and reasoning. The iteration node will process each search term individually. Here's how iteration works. This node receives the JSON array from the planner's flow state. It then loops through each search object in the array. It provides iteration.query and iteration.reason to subsequent nodes. Then it collects all results for final analysis. The key benefits of this node include parallel research, structured data flow, scalability, and comprehensive coverage. This iteration approach allows our financial research agent to be thorough and systematic, ensuring comprehensive coverage of complex financial topics. Step 4. Configuring the search agent. We'll add another agent, and this time we'll rename it as Search Agent. Now we'll set up our search agent using GoogleGenerativeAI. This agent executes the individual search queries from our iteration. For the search agent configuration, we'll configure the model settings by selecting Model as GoogleGenerativeAI, expanding the parameters and configuring as needed. For the messages configuration, we'll select Role as System. For content, we'll input, "You are a research assistant specializing in financial topics." Given a search term, use web search to retrieve up-to-date content and produce a short summary of at most 300 words. Focus on key numbers, events, or quotes that will be useful to a financial analyst. This system message keeps the search agent focused and ensures concise, relevant summaries. For tools configuration, we'll add Google Custom Search Tool. Make sure you have your Google Custom Search API key configured in your environment variables. For knowledge and memory settings, we'll enable memory by toggling it on, and memory type should be all messages. For input message, the search term is iteration.query, and the search reason is iteration.reason. Remember, these are from the JSON structured output, which was configured in the Planner node. This setup passes both the search query and the reasoning from each iteration, giving the search agent context for more targeted research. We'll return response as user message. This ensures the search results are formatted properly for the next stage of processing. Step 5. Configuring writer. Agent. Finally, we'll add another agent node and rename it as Writer Agent. Let's configure this agent using Chatanthropic, which is Claude. This agent synthesizes all the search results into a comprehensive financial analysis report. For the writer configuration and model settings, we'll select Model as Chatanthropic, expanding the parameters and configuring as needed. For messages configuration, we'll create a system message with Role as System. The content will be, "You are a senior financial analyst." You will be provided with the original query and a set of raw search summaries. Your task is to synthesize these into a long-form markdown report of at least several pages. This system prompt positions the agent as a senior analyst capable of producing professional-grade reports. For memory configuration, we'll enable memory by toggling it on and set memory type to all messages. For the input message, we'll include the original query using form.query and the summarized search results using iteration agent flow 0. This configuration provides the agent with both the original user query for context and all the summarized search results from the iteration process. The iteration agent flow 0 variable contains the aggregated results from all search iterations. We'll set return response as user message. For advanced features, knowledge document stores can be added for additional context, knowledge vector embeddings can be added for semantic search capabilities, and tools can be added if needed for specific analysis tasks. The key insight here is that the writer agent receives the original query to maintain focus on what the user actually asked for, while also getting all the research data gathered through the iterative search process. Let's test our financial research agent with a comprehensive example. For our test query example, we'll use Analyze Tesla's Q4 2024 earnings performance compared to analyst expectations. What factors are driving recent stock movements? Here's the expected workflow execution. First, form input, where the user submits the Tesla query. Then the planner response is generated. Next is the iteration process that processes each search term. Then we get search agent results, where the first iteration gathers Q4 earnings data, revenue figures, and EPS comparisons, and the second iteration collects information on stock drivers, market sentiment, and analyst upgrades or downgrades. Finally, the writer creates the final report that synthesizes all data into a comprehensive markdown report covering an executive summary of earnings performance, detailed financial metrics comparison, analysis of stock price drivers, and market context and future outlook. The expected output format should be a detailed markdown document with sections, bullet points, and quantitative analysis suitable for financial professionals. Congratulations! You've built a sophisticated financial research agent with advanced features. Your agent can now handle complex financial queries, conduct systematic research across multiple sources, and produce professional-grade analysis reports. Thank you for following this comprehensive tutorial. Please make sure to like and subscribe.